team, if you would please, position yourselves to reading ultrasound positioning for smart tool applications. The person incorporated in the group. Is Eric Stosser here? Great. Let's appreciate this team. Oh, next slide. Sorry. Good day, ladies and gentlemen. We're the team that worked on the portable interactive platform for behavior analysis and speech and language disorders. Team members are Kishore, who worked on the speech activity detection coding, Tim, who also helped with speech activity detection coding, but he also helped each of us out in our individual parts. We have Ryan, who worked on the Android programming for the interactive display, and Thomas worked on the data acquisition and analysis, and myself, I worked on the distortion and measure coding that we programmed in MATLAB. The main goal of our project was to design a supplemental tool to be used for a target 5-year-old girl who's been diagnosed with autism. Even though this device was designed for her, the flexibility and the potential for it can be used in other fields. The flow chart demonstrates everything that we need to do in order to accomplish our goal. The main part was the interactive display, which has two modes, an admin mode and a student mode. The admin mode allows for different levels of words to be selected, and then the student mode is where the subject interacts with our program, and then a microphone is turned on and captures the audio. Then the SAD or VAD is the speech activity detection. We don't want any of the silence. We're not analyzing that, so we cut that out. And then the LPC and the measures and all of the comparison is done in the distortion measure part of the coding, which weighs the audio from the subject and the reference libraries. And then all that information is stored. There's a chart that shows it, but this information is stored for later history that can be pulled up for scoring as needed. Some of the challenges we met were software to hardware handshakes. Obviously the data analysis was pretty tough. One of the things, when we finished writing the code in MATLAB, we had to put that on the Android tablet. We were going to use Python as our go-to, but then that wasn't very, some of the stuff didn't translate. So we were able to use Octave, which is an open source code, kind of a bare bones MATLAB. We reached out to other experts in the field, and we gave them the survey. 75% of them agreed that our approach for the scaffolding of the word system was a viable approach. And we were mindful of some ethics situations. The audio we used was from a young girl who got burnt with SID, so we can use that over again. We made sure to use open source coding in order to make this program usable for everyone. Some future work would be some more versatility on the interactive display and some more data analysis so that a wider spectrum of measures can be had. Thank you for your time. Are there any questions?
So this is a software-only platform, or did you develop some hardware?
No, it's software. Ask us about speech activity detection. And Tamgo.
So for our speech activity detection, we started out using VAD Zone, which is available in the voice box toolbox for MATLAB. And we originally started with that, and that provided us some very good speech activity detection. We were able to efficiently remove silence. We had about 90% detection of speech where there was speech. Then we later on moved to some more complex SAT, but unfortunately the translation for that into the use of that with the Octave library was didn't go over so well. So we